Hi, welcome at the YouTube channel of the SCS project. Today I'm here with Kurt Garloff, the CTO of the project, and I'm Friederike, community managerin of the project. And today we want to give a short overview of the project, what we are achieving, what we offer, and how we work together. Welcome, Kurt. Nice to meet you.
Nice to meet you. Thanks for the invitation. Good to be here.
And what is SCS? What is behind this one platform?
So when we created Sovereign Cloud Stack, we had the observation that there's a lot of great open source technology out there. Open source technology that allows you to build digitally sovereign cloud and container platforms. But we also observed that there's a huge amount of fragmentation in the open source ecosystem. And that was leading to a situation where a lot of companies that wanted to build such platforms did a lot of work and actually had to do a lot of work in order to integrate all those open source technologies into something that is a coherent platform. And there's actually no need for all of these companies to do that work on their own because, and that's the idea behind Sovereign Cloud Tech, we can do that together. We can collaborate and share the work and create actually a platform that where not everybody has to duplicate that work and end up with slightly different, slightly incompatible actually versions of a very similar stack, but actually do something where we end up with compatible solutions and with a platform where the work is not done 100 times independently, but it's only been done very few times, ideally maybe only once. And we agree on that is the best way to integrate things and to build the software and to expose it to users with the same interfaces, APIs, standards.
And what is the very heart of SCS?
So the very heart is, I think, this idea of doing that together. But when we think about what that means in real life, and maybe I can jump to a slide of what we're doing, it really comes down to our understanding of digital sovereignty, and that drives the various activities we have. So I already said when we want to build a common platform together, that we base that platform on the same standards. So we do build standards together. We agree on, okay, what is it that users of such a platform expect from that platform? What are the standard interfaces? And what is the system behavior behind that? And if we can actually agree on that, that has the huge advantage that a user that is using one solution from Sovereign Cloud Stack and he wants to change to another provider, he can actually do so without any surprises. So the platform will behave exactly the same way. It will feel the same way. So you can actually go from one provider to another one, or you could actually decide you want to use them all together. So you can actually say, okay, I'm maybe a large customer. Maybe I have several partners, several providers from the SCS ecosystem. As long as they use those same standards, I can easily integrate all of them in my IT environment. So that's the standards view of it. And yes, of course, in order to kind of prove that those standards are being fulfilled, we make them certifiable. That means you can actually check and whether they are being fulfilled by a provider. The provider can prove to his users that those standards are being implemented correctly. And one thing we also do then as a project that keeps those things together, we make sure we keep people honest. So those standards are also tested on a continuous basis, on a nightly basis by automated tests that we have written for that. Second big pillar is, well, we have now agreed on a common system behavior, on common standards, on common APIs. There's, of course, many different possibilities to implement those standards, and that is the nature of a good standard, that there's many possibilities to implement them. But if we want to do it very efficiently and not do a lot of double work, we can, of course, also come up with a reference implementation with software that already implements all of those standards. And then providers are free to choose to use that reference implementation or maybe not use it. And that's not a black and white thing. The word modular has meaning in this sentence. Providers can choose that certain components, they use the pre-integrated reference implementation, then other components, maybe they have very special needs, or maybe they have history with a pre-existing platform. They can continue to use a different implementation, their own implementation, if they like to, and then still in the end save work by using at least some of the common parts that we have developed as a community. And of course, all of that implementation is open source, or maybe I should say it's openly developed open source. So we believe in the four opens of the open infrastructure foundation, that we have not just a fully open source implementation, but also use an open development model, use an open design process, and have an open community. Third thing, building the software is obviously a lot of hard work to do that well. But as hard as building the software and implementing the standards is actually operating a platform in a way that is highly reliable, that customers really want to rely upon and can trust. And in order to achieve that, you need to have a lot of very skilled, experienced engineers that are driving the operations of your platform. One of the things we want to do in our project is also making that operational process easier. And we have learned in the last few decades that collaborating on software development is very beneficial for those that participate in the effort. We want to do the same now for the operations tasks. So establishing ways for operations teams to share knowledge and to collaborate on running platforms makes all of us better, because we can learn from each other, and this way not need to start from scratch. And obviously by building such a network of operators, we make it easier for smaller companies that have a small staff, they can only afford a small amount of engineers to be successful in operating complex platforms, because those are still complex platforms. We are trying to make them easier, but I mean, it's still a large, distributed, highly dynamic system, which is not a trivial thing to do. We call this initiative Open Operations, and we have some write up on that, what are kind of the driving paradigms that we want to use to share the knowledge and create transparency into operational things. Also transparency, and that's maybe something that is unusual to operations teams that lived in the traditional space. Also create transparency on things when there's challenges, when there's issues, when you are under attack, or when there's a problem in your platform. How do you do the root cause analysis? How do you analyze this? How do you learn from that? Of course, internally also, but then also how do you maybe share some or most of that knowledge so others can benefit from that? And likewise, if others share such knowledge, of course, you will benefit. So in the end, we all benefit from that.
Yeah, thank you, and I will link the manifesto of the open operations in the comments. But to go on, you just, or you paint the picture of standards and adoption or usage of SCS and the modular reference implementation. How can SCS be used, and how is the adoption, and what is your, or the bigger picture, what do we want to achieve in the future?
I mean, the idea is really that with the common standards, with making it a lot more easy to implement your own cloud and container platform, that we have the ability to create a network of clouds, a network of clouds that is holds together, that is held together by having common standards. So that is actually what is kind of shown here in this picture. We have standards on the infrastructure virtualization layer and standards on the container Kubernetes layer. And by having clouds that implement those clouds become connected. I mean, they are, of course, even better connected if we also share some part of the implementation and the open source code, and also if we share some of the operational practices and provide the transparency. So actually, it goes across all the different deliverables we have in the project: standards, code, and open operations. And those clouds, by making it a lot more easy to have them on your own, we want to build a network of public cloud providers that offer clouds for their clients. But it also gives you the ability to build private clouds. So as an IT department for a medium or for a large company, it can be a very good decision to build your own. It can actually save a lot of money if you have that capability in-house. And we're trying to make it easier. But even if you build your own private cloud for your own various lines of business, it might still be very beneficial for you to connect to the larger SCS world. So maybe sometimes you have spikes in your load and you need to scale out to public cloud providers. Knowing that there are public clouds that are perfectly compatible with what you've built in-house, of course, makes that a lot easier. It also actually gives you some assurance that what you are doing, you're not the only one, you're not alone. If there are challenges, you will not be the only and first one to find them, because there's a community out there of people that run more or less the same stuff. And they will also run into the same issues if there are problems. So you can actually work with them together to resolve those issues. And obviously, seeing the dynamics of that happening, a lot less issues will hit you, because the quality of the overall thing, of course, gets better and better the more people use it in real life, and then help us to work out and find the limitations and issues and resolve them. So this is really the idea of this resilient network with a lot of cloud providers, private clouds, public clouds, clouds in administration, in the public sector, cloud in research, and of course, clouds for industrial partners.
Very good. This virtual hyperscaler, which could be built, would this be digital sovereign?
It could be, at least. Depends, of course, how the various parties that implement those clouds are implementing them. But I think it's an important topic to talk about digital sovereignty, maybe real quickly, because it's a term that's being talked about a lot. And the discussions on digital sovereignty are sometimes difficult because different people have different understanding of what that term actually means to them. And in order to participate in that discussion, and of course, sovereign cloud stack has sovereign in its name, so we need to also understand what we are talking about when we talk about our own technology and standards and ideas. So we have actually done a bit of work to define the term well for ourselves, for our community. And there's lots of discussions with our community and with our partners and ecosystem that went into that. And we also ended up publishing this in an article in the German Datenschutz und Datensicherheit journal. So that's that you could actually have a long version to read there, but I'll try to quickly summarize that. And the summarization really is based also a bit on what we see in the market, what different companies talk about when they say we are sovereign. And we have actually put those different aspects, those different dimensions on a scale. So we have built a taxonomy, if you want to say so, of those various attributes. And we start with the lowest level, or the basic level. That's certainly for European companies extremely important, which allows you to be legally compliant with regulation that exists, which is the Data Protection Act you need to be compliant with. And that is something that most people that claim digital sovereignty at least try to fulfill. And based also on the fact that this is a legal requirement, the SCS community has not come up with own definitions of how to fulfill those, but we really reference the organizations that do that. There is ENISA at the European level that has a very good definition of those things you need to do. There's the Gaia X initiative with the labels. They actually connect to also what the ENISA does. And of course, sometimes there's just the written law that you need to comply to. And we have no positions to know better than the lawmakers. So that thing has been taken care of, I think, reasonably well. Some people call this level also data sovereignty. So that is basically what allows you to control how your data is being stored and who has access to it. On the next level, one of the things we've seen is very important to companies that want a certain level of sovereignty is that they have choice. Because, and it's something we see currently in the industry, not having choice can be extremely painful. And there's a big virtualization platform software company that has been acquired recently, or well, a year ago almost already, and is now increasing prices drastically. At least for some of their users, prices are increasing drastically. And the companies that are using this software, they are now in a very painful position because they actually find out they have not built their IT in a way that they have choice. So they are really dependent on that software company now, and they have to pay a rather high price for that. Same thing, of course, if you're using a hyperscaler cloud and start to use all the platform services that those hyperscaler clouds offer to you. That creates a huge amount of lock-in, and just the technical cost of switching, of rebuilding all your workloads and applications to become independent from all of those specialized services and APIs, again, is huge and often prohibitive. So that's basically not even possible. So we're trying to avoid that from the beginning with what we do with the SCS standardization by having a network of many providers that are implementing the same technical interfaces, the same technical system behavior behind that. That switching cost, at least from a technical perspective, becomes very low. And that's what we do in the Sovereign Cloud Stack community with the Sovereign Cloud Stack compatible certification, where we test the technical compatibility. And of course, we base the tests we do on top of the upstream communities compatibility tests as far as they exist. We use them and we work with them and we improve them and we contribute back, of course. But we're using the conformity tests from the CNCF, from the Open Infra Foundation, and then we add some of our own on top of that. So we have a test suite that runs all of those tests. If we go to the next level, companies that now have choice, but maybe they want more than just having choice. Maybe they have ideas how to improve the platform. Maybe they have requirements for their own IT needs. And in order to being able to implement those ideas, one of the things that really helps is if you have the transparency on that technology, you can understand how it works, and then you can make very informed suggestions how that technology can be improved. Or maybe you go a step further and you don't make just a suggestion, but you ask one of your engineers to actually work on that and come up with a contribution to a project. And uh, if I said before that we believe in the four opens, I mean, we do have an open community, and inside that open community, companies that have ideas how to improve the platform are extremely welcome. So they actually, if somebody comes and has an idea, and maybe beyond that idea, even some concept or even code that can be contributed and integrated, that is really the thing that makes open source thrive. So that's what we love, and that actually is something that allows us to also have a technological set of skills and capabilities to shape basically the technology we're using, because now you cannot you can uh, read the code, you can understand the architecture, the code, you can contribute to it, and that makes you an expert in that technology. If you want, you don't need to, but it's an option that can be highly attractive if you have ideas how to maybe create value and innovation at that layer yourself. So that is being enabled by using openly developed open source code. Um, and inside the SCS community, we would assign the label SCS Open to such platforms using fully open source, transparent code that also can be contributed to according to the four opens. Final thing, and I talked about before, that operating such platforms is a hard thing. It's non-trivial. Um, and that would be like the highest level, to also not just make the code transparent, but also the operational processes around that, and allow your peers, your clients, not just to understand how the code works, but also understand how the platform is being run and operated. And by providing that additional level of transparency, you make it, you actually can build a lot of trust with your clients. But of course, you will also be supporting the complete network of SCS providers to make that network stronger, because now other companies can learn from your experience, and likewise, you can learn a lot from other companies' experience. In the end, that makes your operations a lot more efficient and increases the quality of your operations a lot. We've been working with our ecosystem, with our providers, to actually make things happen. So we currently already have things like a public health monitor, where you can actually see how the various clouds do currently perform in terms of reliability, also in terms of performance. If there are issues, actually that is being fairly transparent already right now. And we have been encouraging and working with our providers in case there are issues, actually, that we work together on root causing those issues, analyzing them together, and then also making sure we record the learnings from that, so that same experience doesn't have to repeat it again and again. But we can learn, and thus make the whole network stronger and better.
Yes, I know. And the involved companies are very happy and use this opportunity very often. But going further, you mentioned the architecture of SCS. Maybe we come now to the reference implementation. What are we offering at this level?
Yeah, great question. And of course, talking about the great software without having an understanding what are the software components is a bit theoretic and hard to get a handle on. So very happy to deep dive quickly into what our software stack looks like. So this is an architecture diagram of the reference implementation. And I'll start to basically at the bottom in the center layer. Well, we have standard commodity server hardware. That's not part of the stack. That's obviously something somebody else delivers. But that's what we built then on top. And what we built on top of that is basically virtualization for compute, storage, and network. We're using the open source technologies that you would probably expect there on the compute side, Linux with KVM hypervisor. On the storage side, it's the Ceph distributed storage technology. And on the networking side, the open virtual networking OVN technology. We expose those virtualized resources with a set of APIs, so you can build applications on top of that are fully automated, that are actually cloud native, and we're using the OpenStack core services to offer those that platform to offer those services as with a standard interface that's well known and well established and well proven in the industry. Then, of course, what we have these days is that most new cloud-native applications are actually containerized applications, and they're written and developed against the Kubernetes set of technologies. So on top of the virtualization layer, we have a container layer where users, developers can actually build Kubernetes clusters on demand. So it's really a Kubernetes cluster as a service solution there. We're using the cluster API. That's a very successful upstream Kubernetes cluster management project. And we've built around some additional tools to make sure those clusters are well manageable and integrate well into the underlying platform. And that's what the cluster stack technology from our partner is delivering here. So that's really the functional stack of Sovereign Cloud Stack. In the picture, you also see platform services and federation services. These are not really part of Sovereign Cloud Stack, or at least not yet. But I mean, we have partners we work with that build these things on top of SCS, and they integrate well with SCS. That's why we have them on the picture, because I think they are relevant to a lot of users. Let me maybe then quickly also go into the pillars on the side. On the left-hand side, we see operations, really the set of operational tools that we have delivered that support operators in their daily and regular work. A lot of automation, of course, automation to deploy and manage all the software, the lifecycle management, installing the upgrades, making sure you have a complete overview over the software you're using and the versions to make sure, for example, that if security issues are found in components, you're able to determine whether they affect you or not. And then monitoring is a significant part of the work that you do in operations, making sure you understand whether your platform works well, whether it's healthy, whether you're running out of capacity in some aspects of your platform, so you can react to that. Metering is important because you want to assign cost of running the platform to your customers. Logging in order to be able to, after the fact, be able to find out if something has gone wrong, what has happened. Right-hand side, finally, is the user management. Identity and access management is the IAM abbreviation. The important work we've done there is to make sure that your users can be managed not just locally on the platform, but we are able to federate out to identity providers outside of that platform. Those identity providers actually could be another SCS platforms. If you build like this network of clouds, maybe you want to manage your users only in one of those clouds, and then use the identities across the network of clouds that you have. Or also something that we see very often, companies have corporate directories where they manage their employees, and sometimes also their suppliers and customers. And they want to be able to connect the cloud to that corporate directory, and by assigning users to groups in their corporate directory, actually manage their ability to access certain projects in the clouds they are using. So that's something we have worked on and enabled in that work. And then finally, you see this orange border around that, which has the lock symbol in it. This is really the overall approach needs to be guided by security. We call that, or it's sometimes in the industry, the term security by design is being used without necessarily everybody having the same understanding of what that means. But when we built the architecture, we really were very aware that this needs to be suitable for public clouds. Public clouds, of course, are always exposed to a lot of security attacks. So it needs to actually survive these scenarios. And then obviously we also talk to some industry partners that want to build private clouds exactly for the reason that the public clouds are not secure enough for their use case. So we have built-in features like a capability to deploy such a cloud and manage and run it in an air-gapped scenario. We have taken some architectural decisions like having the strong virtualization isolation to actually also isolate your Kubernetes clusters. That helps you to make sure you don't need to rely on just the namespaces to separate workloads from different customers and different departments. Even we have implemented an automated pen testing approach. That's something I believe that is fairly new, where we have actually worked and paid highly skilled penetration testers to basically hack our platform and then ask them to actually start integrating those attacks into automated tools that we've made available and that we now run on a regular, typically nightly basis against the platform. And that, of course, also helps to improve the platform. If you look at this architecture diagram, that probably also helps you to understand a bit how we have structured development process, because we have basically teams that work on those various layers and components of the platform. So we have a team infrastructure as a service that looks at the virtualization layer. We have a team container that looks at the Kubernetes platform at the container layer. We have a team that looks at the identity management. We also have integrated the security topics there. And we have a team around the operational things. And each of those teams consists of interested people from the sovereign cloud stack community. Some of those people are from providers, for example, that use our technology. Some of that community or some of those community members are actually people that we pay for doing development work for us. So as a publicly funded project, we're grateful actually to have money from the German government. And we used most of that money actually to pay our development partners to do development work for us. And we've, of course, as this is public money, we've used public tender processes to find those partners and then use the partners that could offer the most skills to contribute to our project.
Wow. Yeah. That was done during the last 3.5, maybe 4 years, and yeah, it was a great achievement and very complex and very integrated software stack, and additionally the standards and the open operations initiative. Yeah, was a great effort and a very great achievement. And yes, thank you for showing this slide. There are some, not all, but some of the community partners of this great community.
Yeah, so this is a snapshot from our homepage, I believe. Sorry, some automation with slide flipping apparently going on here. This is a snapshot from our homepage showing some of the partners we're working with. There are some more partners. Not all of them have allowed us yet to show their logos. But I mean, at least some of the important ones are definitely there, and they have different roles. Some of them are cloud service providers offering public clouds. Some of them actually build clouds for the internal consumption. Some of those clouds actually are not using our reference implementation, but have pre-existing technology. And we have worked with them, and they made their pre-existing technology and configured it such that it becomes compatible with sovereign cloud stack standards. So they're actually listed in our standardization certification page as being tested on a nightly basis, just like the other ones as well. So you can see that they are fulfilling the standards. There's actually a new one that's not on the slide here yet, which is SysEleven, which has also used their existing solution to implement the standards. Also very nice collaboration. And then we also have partners that are really mostly in the business of supporting others in building up SCS clouds. So we call them implementation partners, and they are very skilled and successful in doing so. So they are, meanwhile, experts in SCS technology and how to use them and apply them.
Thank you very much for this very short but intensive overview of the whole project. Thank you so much.
You're very welcome. Thanks. It was a
Always
pleasure.
a pleasure.